Okay, we're off and running PF1 video 2, and so we're going to continue our journey here. That we're going to spend. It takes us 4 days, part of 4 days, I guess. So anyway, that's going to be Monday today. Oops, not this Monday. Make a note. We don't have class on Monday because of Labor Day, so we'll meet a week from today on Wednesday, and then it'll actually get bumped over then into the fourth lesson on the development environment. We'll get bumped over into a week from this coming Monday then. So actually the first of week, wow, 3. But so learning the command line environment, we talked about that. I kind of, mentioned that the neat thing about learning the command line, then you take these commands that you can type into the command line and you can put them into a text file and have them executed as a program. So the little shell script that I use to create your accounts, for instance, well, it's just a bunch of commands that I could type in one at a time, or I can type them in once into a file and execute the file as a program and automate that. So work you do on the command line lends itself to automation. And PF2, I mentioned, it's a challenging class, and so at the beginning of PF2, as kind of a little motivational talk, I guess, with those students to kind of get ready and show them the importance of learning that material and doing a good job, because the skills you learn in PF2 are absolutely those that are wanted and are going to be tested for as part of skills tests, logic tests that you have to take in order to get a job. Isn't that rough? And so I have a bunch of emails I've received from former students over the years. And again, I handpicked some of those to show my PF2 students, but I want to show you just one just for the heck of it here, I guess. So this is a student that went through my program at AC and then transferred down to Tech and got a bachelor's degree in computer science at Tech, and then went into the workforce. And we stayed in contact off and on, and occasional email back and forth. And I don't know, for some reason I had thought of John and sent him an email, and he replied back and kind of let me know how he was doing it at that point. And so let me share at least the first part of his email then. All right, so we'll pull that over here, and there we go. So if you guys would, give that a quick read. Give me a thumbs up when you're done reading it then. All right. Looks like y'all guys are getting to the end then. So I found myself in the same situation as John did here regarding command line. I've worked for a number of companies over the years, continued to do contract work on the side even now. And, everybody knows how to navigate systems using the graphical interface. It's kind of common sense. It's easy to learn. You kind of poke and prod, and eventually you end up where you need to be, and you kind of get things done even if you're not a guru, The command line's harder to learn, but it's more powerful once you learn it. And so it will happen regularly for me, and here it did to John, that when something needs to be done that gets pretty awkward, pretty clunky, kind of difficult to do in a graphical interface, they will try to do the same from the command line, or perhaps find someone that's knowledgeable working with the command line that can help them out. And John had that exact experience. He is the go-to guy for command line. You want to be the go-to guy or gal for any number of different things. Your employer, your immediate manager, and so on will recognize that this is someone that can be counted on to get stuff done. And you want to be that person. And anyway, he's the go-to guy, and this is his words, not mine. The command line is king. Isn't that funny? Because it's the older, clunkier in a lot of ways interface, but at the end of the day, for a skilled person, it ultimately is much, much more powerful. All right, that being the case, there's a reminder. I still have some students that haven't finished Lab 0, so make sure and where you send me your IP address, and also then where you send me the email that says, yes, we've looked at the syllabus and the policies, and I'm aware of those things, and send me an email to that effect then. So if in doubt, refer to your notes for Monday, or look at the video then on Blackboard then from Monday's lecture towards the first, where we assign Lab 0. So make sure and get that done also. All right, back to our server then. So get logged in, everybody, if you're not already there. Question?
Yeah, this keyboard is slipping.
The keyboard's not working right?
Yeah, I switched ports and it's still not working.
Oh, you plugged it into a different USB?
Well, the original one, I was just put it to see if it worked, and it's still not.
Okay, well, good heavens. If you would send me an email, and I've got a note I already need to send to IT regarding a couple systems not rebooting correctly at night. If you would send me an email to remind me, and I'll put system number 7 that has a sketchy keyboard on there then, I guess. Thanks for that. So get logged in if you want. And so turn to your notes. Let me catch up with you guys by opening up my notes. So we're going to teach you a bunch of Unix commands. So we'll be going back and forth here, especially early on, to your Unix command reference. Unix command reference. So for a total of 2 commands. Hey, we all successful in changing your password? Get that done pretty quick. The truth is I can't tell you what your password is. It's stored in an encrypted format. But I can recognize the encrypted format for let me in. So I can tell if you haven't changed your password, and eventually I'll lock out those accounts that still have let me in. So please do make sure and change your password then. So, all right. So we're going to teach you a bunch of new commands today. So hopefully everybody's kind of logged in here with me. So here on our server, we're all logged into one system, and it's kind of a little different perhaps than what you're used to, like with a PC or a Mac or something like that. Again, the real world operates differently perhaps than what you're used to in your everyday lives as a regular old person. And like at your home PC, we talked yesterday about, do you have multiple accounts there? And some do and some don't. But, you know, can multiple people work on your home PC or Mac? Well, yeah. One at a time, right? You know, you got one keyboard and one mouse, and whoever's sitting in front of it has control of those. That's it, you know. So the other people, you know, now granted, we might hang a printer off of a PC or a Mac or something and be able to access that printer remotely, or maybe we could have it sharing some file systems remotely, or different things like that. Maybe there's a web server on it and we're accessing those web pages remotely. But if you want full access to a machine with a graphical interface, you need to force your way up there and get a hold of that seat and the keyboard and the mouse, and there you go. It's one person at a time. But the neat thing working about on the command line is all of us right now are logged into this one server, and we all have full access to it, and we can do anything that we want. So one command we'll show you right off the bat here. I guess we'll add it down here, I guess. Won't come down here. Then we'll type her in. To list the users that are currently logged into the server, you can run a command called who. Lists the users currently logged in. So we'll go over here to the server then, and we'll kind of verify that and take a sneak peek and verify that we got a decent number of folks that are logged in here already. So who, in other words, who is logged in? Now note that the command doesn't get executed until I hit enter. That's kind of the submit button, if you will. And you know, you can backspace it off to fix errors or whatever else. In fact, if you backspace it completely off, hit enter again, well, there's nothing to do. It just gives you another prompt. This is the command prompt here. But oh, that's right, who, and I hit enter. And there you go. We got quite a few people logged into the system, and it shows you, oh, the IP address they logged in from and when they logged in, for instance, then. So that's, you know, could be kind of useful, I guess, there. So that's kind of neat. You know, I've been talking about Unix and Linux, and we'll continue to learn more about it as the days come. But let me ask you a question. On your home PC, what's the longest that your home PC goes as a general rule? Throw out a guess. What's the longest period of time that your home PC would run without a reboot? Either it needs a reboot, you decide it needs a reboot, or it decides it needs a reboot, or it crashes, or whatever. You know, what's a reasonable amount of time between reboots like on a Windows PC? A few weeks. Yeah, you know. Back in the day, back in a long time ago, you'd buy a PC, you wouldn't necessarily update it all the time, especially before it was more common, starting in about the mid-90s when everybody was plugging into the internet. You know, the internet existed since the 70s, but our first web browser didn't exist until the mid-90s, and that's when everybody started getting on the internet, was then. But, you know, certainly before then, if your system wasn't on the internet, there was really not much of a need to, quote, update the operating system. But now because of security issues and so on, those updates are more important perhaps. And Windows is also getting better at making sure that you are getting those updates. It really started with Windows 10. It got pretty good then. It's even better since then, where it's kind of a little more difficult to disable those updates and so on. They're going to, as a general rule at least, happen automatically. So yeah, the truth is, excellent guess there, that for Windows PCs, a lot of times a week or two, and then you're gonna come in one morning and discover it's been rebooted automatically, for instance, if you keep it up all night long, you know, for instance. And, you know, for whatever reason, is that good or bad? You know, it's probably important that you do so. But some systems you need up longer than that. You need some systems up longer than that, especially commercial systems and so on. You know, gosh, I remember taking a class one time on a new server that was coming out, very, very, very expensive machines, $1 million machines. And I flew to California in that case to get some training on administering these new systems that we were buying. And I met a guy that was an administrator for a big finance company, like a credit card company, something like that, in Manhattan. And he said that they measured their downtime in millions of dollars per minute. All right, so millions of dollars a minute of revenue that were lost when those systems were down. So they were willing to pay big money to get systems that were very, very dependable and so on. You know, so for commercial servers, having them randomly by the operating system or by necessity for an administrator to have to come in and power them off and reboot them is not really acceptable. You know, because of course you can imagine if you are Discover Card or Visa or something else like that, when's a good time when you can shut down those systems when the customers aren't going to be banging on your servers? Never. You know, around the world, you know, and even if it was, you know, it's around the world, around the clock, those systems need to be up, you know. So Unix and Linux, you know, those are operating systems that are targeted towards servers. And I'm going to say that the better a track record is that a system has on being able to stay up for a long period of time without the operating system rebooting or crashing or whatever is an indication of the stability of that operating system. And anyway, this server that you guys are logged into now, it's a little better than a desktop PC. It's a small end quote server. It barely has any of the things that a traditional server would have. It has redundant fans, and it has multiple disks that you can set up in a striping or a mirroring or something configuration for better performance and for redundancy and so on, so it can tolerate a disk error or something like that. But it's still a very inexpensive little machine. But so I'm running Linux on this small little quote server, and it's just been rock solid. And there's a command that you can run. There's a command. Let's add that to our list. In fact, if we show you another variation of the who command, we'll just say, oh, similar to who. It will show you who's logged in with a little different information. So anyway, so if we type W and hit enter, kind of similar information, gives you the username over here on the side, shows you when they logged in over here. It doesn't list their IP address. Instead, one thing that's kind of handy perhaps is it shows you idle time. How long has it been since this user did anything? All right. So like right here, 1 hour and 1 minute, for instance, you know, 12 hours, 54 minutes. And anyway, 2 seconds, you know, all of us down here logged in just within the last few minutes. Well, then there's not much idle time. It also shows you what they're doing. So bash is the name of the program that is right here, prompting us and asking us to type in a command, and we type in a command, it reads that command, and then it runs a program to execute the command, and it comes back and prompts us again. The program that does that is called bash. Oh yeah, kind of interesting. When I look what I'm logged in from home and also from my office and then also from here in class, but when I look right here, I logged in just before class started. And at this particular instant, I was running a program called, oh yeah, W, right? Oh yeah, I ran the W command to see what everybody was doing, and at the instant that I did that, I was running the command called W. You know, it's kind of like you take a picture in a mirror, and you always have at that time, coincidentally, you always have a camera in your hand for some reason, it seems like. You know, kind of the same thing there. But also notice, all right, that the W command up here at the top gives you some information. We'll talk about it in a bit of detail just a second here. Look at that one line of information there, and let's add another command, uptime. How long has the system been up since the last reboot? Whether it was a reboot or a crash, or whether it's something you wanted to do or it did it on its own or whatever, a command called uptime. And if you type uptime and you notice, hey, look at that. Kind of a funny coincidence, maybe not a coincidence. On Linux, it's not been the case on some versions of Unix that I've run, but anyway, with Linux, the uptime output is also displayed at the very beginning when you execute the W command. They just said, hey, what the heck? We're showing them what's going on in the server here. We'll go ahead and give them the uptime information at the same time. So anyway, we see that the system has been up for just 7 days, which isn't especially long. But anyway, I generally don't bring the system down regularly and reboot it and so on because it doesn't need it, all right? But, you can imagine that if the system had been up for some time And then let's say that we had a thunderstorm come through and we lost power, and the system lost power, then it had to come back up after the power was restored. That you might wonder, I wonder how long the system had been up previously. Well, you type uptime and it's going to say 6 hours or whatever, based on when you come in and when the thunderstorm, came through in the middle of the night. It'll give a short time. Jesus?
I was just wondering, does it say the system's been up since last logged, or?
No, this is how long the system has been up since it was last rebooted. Since it was last rebooted. But yeah, again, the aggravating thing perhaps is if you knew the system had been up for a long time, and you want to find that out after the fact, after it had crashed or rebooted or whatever, then come back up. Well, you type uptime and it says 10 minutes or 2 hours or 6 days or whatever it had been since it came up last. So anyway, hey, what I did is I set up a little deal where the system would execute the uptime command every day at 6 o'clock. This is just for me. So anyway, let me show this little file here. Uptime.out. So check this out. I've been doing this, well, good heavens, this is for whatever this is now, for 7 years. So for 7 years, every morning at 6 o'clock, it shows how long the system has been up. So anyway, I started this, it looks like right after I'd done some administration work or whatever. Okay, so the next day had been up 1 day, then 2 days, and then, oops, I brought it back down again for some reason. This was at the, in between the summer sessions were over, and we're getting ready for fall, and I might have done an operating system upgrade or something else like that. Anyway, then, okay, the updates are done, and we're off to the races. All right, and this was again back in 2018. And anyway, we stayed up and up and up and up. In fact, I'm going to skip through a little quicker now. And eventually, we're about to get to the end. This is a pretty good run. This was a pretty good run. This is continuous uptime without interruption. 1,211 days without a reboot. That's over 3 years. All right, 3 years and 2 or 3 months, something like that, without a reboot. Does that sound like a pretty stable operating system? Oh my gosh, it is. And again, this is a little PC running down in a closet down there running Linux, which I downloaded off the internet for free. Anyway, that was the best that I had done for a long time. And it was a power failure that we had here. All right, it was a power failure that we had that brought us down. So rats, okay. So once again, once it goes down, I'm probably going to do, it was up for a few days, then I brought it down. Now it's starting again. And anyway, now we're off to the races again. And this started in early 2022. Early 2022. The time to beat is 1,213 days. 1,213 days is the time to beat. And we did beat it. And now we're getting closer to right now. See, hey, this was the end of July in 2025. This was just a week or so ago. And we've set a new record. And to be clear, this is the longest in my entire career I've ever had a server up. I've administered lots of systems, but in the real world, they tend to need upgrades regularly. Hey, we've got more users, more data, we need to upgrade the system. A lot of times it's send this one out and bring a new system in and put it in its place. It's literally replacing the system, but it might be adding memory, adding processors, different things like that also then. So anyway, those systems in the real world tend to, you'd be lucky to see them stay up for 6 months or a year or something like that. So good grief, that one was over 3 years. Here again, we're up to over 3 years. And in fact, we made it to 1,323 days. And that was just last week, just a week ago. And if we had made it to January 2026, that would have been 4 years without a reboot. But I was at home the next day, and all of a sudden I couldn't get to the server. And so I tried to ping it, and I tried to access from another system and so on, and I couldn't. Scratched my head and, was doing some other testing to make sure it wasn't my network and wondering if it might be the campus network that was down or something else like that. And a few minutes later, it came up. Well, that's weird. We didn't have any thunderstorms coming through or anything else like that. And I then logged into the server. Now, this is some stuff I added in here then myself, just as a record. And then I looked on the server, and what did I find? Well, so there's a few other servers in this little closet down the hall, and I guess they're not especially well marked. And one of the other servers needed an update. And in fact, I think the other server was powered off. So I don't know who. I don't want to know who. You know, I'm not here to cause trouble. Again, I'm grateful to have that server, to have access to that little computer room, to have access to this lab. So I'm not going to complain at all. But somebody must have thought that they were powering up their system by hitting the button on the front of it. But they hit the wrong button on the wrong machine, and they powered my system off. And then, of course, the screen woke up, and it showed the messages of the system was powering down and all the rest. And then as soon as they realized that, oops, after it powered off, they hit the button again and brought it back up. And there you go. So rats. So we've got this 3 years and 8 months. 3 years and 8 months now before we can touch that record. And I'm not sure if I'm going to be here in 3 years and 8 months, to be honest. So that's probably the longest I will ever have a computer server up. But I want you to take a look at that and recognize that, you know, Unix and Linux, those are commercial grade operating systems that are intended for servers that need to be up. All right. And that one certainly was. And, you know, the fact that it was never rebooted during that time, it was never compromised in any way. There was never any hacking attempts or anything. Well, I can't say there was never any hacking attempts. There most certainly were. But I've got all the doors closed with firewalls and so on, and they were not able to exploit anything. So anyway, it's a secure, stable operating system. So once again, it is a system you need to learn. All right, so there's that. Good number of commands there. I think maybe what we ought to do now is we need to start talking about how do we all share this one computer in terms of the file system. Does that mean that we can all access each other's files and so on? Because, you know, for the most part, like on your home PC, if you just go there and everybody's logged into the same account, then, you know, you just have a little friendly agreement. Okay, you'll put all your files in this folder, and I'll put my files in this folder, and we just kind of trust each other to not mess up each other's files or whatever, you know. But would that gentleman's agreement work very well in this kind of environment? No, not if you're expecting students to do their own work on labs and so on, if it was easy for them just to go look at somebody else's or whatever. So it works just fine. You'll have your own little private area of the file system that's just for you, that you can use, and nobody else can get to and so on. And we need to show you a little bit about the structure of the file system for Unix then. So we're going to do that next. So let me go here. And we can get rid of this one from yesterday. Okay. And here. All right. Good grief. What is all that? That looks like the end of last semester in PF1. Okay, so there's that. Okay, let me get my little pencil sharpened up here and ready to go. 2 or 3 pixels wide. I can't see over there, unfortunately, because of the little yellow stripe, but we'll see if this is okay. All right. The Unix file system. It is an inverted tree, if you will. You know, when you think of the Unix file system and what we're drawing here, it's kind of sort of similar to the C drive on your home PC. And you've got C:\/ at the top, and then everything comes down underneath that. They call it a tree, but, well, a tree grows up, if you will, so it's kind of like the roots of a tree or whatever, or they just call it an inverted tree. So at the top of the tree, all right, this is called root, or the root. So the very highest level directory in the entire file system is called the root. And when we want to represent its path, it's just a single slash. It's not a backslash. It's not a backslash. It's a / We just call it a slash. So anyway, you know, Microsoft, when they created their file system then for DOS all those many years ago, they wanted to, they certainly borrowed any number of different ideas and so on from Unix, but they decided for whatever reason, well, they're not going to use a / they're going to use a backslash. And of course also in Windows you have to put the drive letter indicator, you know, C:\/ or whatever, you know. And yeah, speaking of that, since I mentioned Windows and their file system and so on, you know, every once in a while we'll have a student that says, hey, this is kind of neat what we're learning here. And we see that in some ways Unix is like Windows. All right. So to be clear, no, Unix is not like Windows. Unix was created by those old hippies in 1969, 1970, when Bill Gates was in 4th grade, all right? So Unix precedes Windows, and if there's any similarities there, it's because Microsoft copied Unix, not the other way around. All right. So the root, is the highest level directory. All right, some common directories underneath that. So a lot of times in books and web pages and here in class when you're drawing a picture of a file system, directories, I probably have been using this term directory already, and some of you are wondering, what the heck is a directory? Let me do something here real quick. We mentioned this yesterday. You come down here to the little app searcher or whatever and type CMD. And again, we showed you this very thing yesterday. So this is a command prompt that will allow me to type in commands with a command line interface to the Windows PC that I'm running up here. And anyway, so it shows me, hey, here's my command prompt, just like Bash gives me a prompt. It's waiting for me to type a command, for instance. And anyway, if I want to navigate the file system and look around and see what's there, I would type dir. Dir is short for directory. And oh yeah, okay. So I am currently in my MC Usenik directory, which is under the users directory, which is under the // directory. And when I use the dir command, which again is short for directory, to see what's there, you know, look at these things I have over here. Oh yes, I've got desktop, I've got desktop, and inside of desktop, there, oops, I can't click on that dir, cd to desktop. Hey, there we go, dir again. And oh, I've got this one link here, plus some other things that are kind of common across all logins. But anyway, so note that when I'm looking under my MC Usenik directory, I have a directory called desktop and a directory called documents and a directory called downloads and all the rest. And note it even shows here. They are directories. They are directories. Now, yes, if I, all right, users, MC Usenik, here's those same things. All right, now we're looking at two different versions of the same thing. Looky here, 3D objects, contacts, desktop, documents, downloads, the exact same things. All right, but you know, with Windows and the graphical interface, they would call various things folders. Folders contain files, folders contain other folders, and so on. But we see that even in Microsoft Windows, lurking under the covers, contacts is not a folder, contacts is a directory. It's just that the graphical side of things represents it as a folder. So all right, the lesson for you guys, of course, is a directory is the same thing as a folder that you're more used to working with. Okay, so some common directories, and I'm just going to draw just a handful in here. How about a bin? Bin is short for binary. In other words, text files don't reside here. Instead, it's compiled programs. And what resides here are executable programs. All right. So of course, Unix was written in C, and so there's C programs that were written for, well, what C programs might they have that might reside there? Well, for instance, oh, wrong thing to bring up. How about this? Well, password is a program, and who is a program, and W is a program, and uptime is a program. Anyway, all of those programs, they're written in C and compiled up. We don't need to look at their source code. We just want to execute the darn things, and the executable often would reside in underneath the bin directory, or there's one or two other common places where they might reside also, but we'll just simplify things for now and say the bin directory is where many executable programs reside. How about etc. All right, we pronounce that as the etc directory, like etc. All right, that is a T there, almost looks like an F. ETC, etc. And here we have config files. You know, do we have any Windows gurus? You know, I don't really consider myself a Microsoft Windows guru. I've been a user of it for many years, and I've fumbled and stumbled my way through and done lots of things in terms of configuration and so on, but I'm no expert. But when things get really, really tough, you know, if you're trying to figure out how to do something with Windows and you're reading some things online, every once in a while it might tell you, uh-oh, you need to edit the... Complete that sentence for me. Can anybody do that? A real scary thing that you might every once in a while need to edit related to system administration tasks. Oh, very good. Edit the, oh no, the registry. And you know, when you edit the registry, a lot of times there's warnings. Don't goof up when you're editing the registry. So the registry is this mysterious, you know, cloud somewhere that's lurking in an unknown location in Windows. And to edit, you have to run a special, to edit it, to look at it, to modify it, you have to run a special tool, some kind of a registry editing tool. And if you're editing the registry and anything goes south, you know, like you lose power or whatever, your program crashes or something, you can corrupt the registry. And because the registry is where all of the deepest, darkest configuration settings for the entire Windows operating system resides, And if you manage to corrupt the registry, your system can have big problems. You can have lots and lots of problems. So they tell you, be careful editing the registry. You might make a copy of the registry and then edit it and try it out and have the backup copy just in case and so on, you know. And anyway, it's all kind of a mystery. The registry is, you don't know where it is, you don't know exactly how it's formatted and so on, but you use these tools somehow to look at it and to edit it. On the other hand, with Unix and Linux, configuration information is just stored in text files in this directory. Information on users and groups and passwords and networks and web services and lots of programs and so on. They store their configuration information in files that reside under the etc directory, and the administrator can go over there and just look at them with a text editor. If desired, he can modify them with a text editor, restart the service, or give it a little tap on the shoulder to say, hey, go reread your configuration file because I made a little change to it. And it's much less mysterious. It's much more open, if you will, much more available. And that's kind of a cool thing about Unix. All right, let's see here. How about, trying to think, what do we want to do next? We might just go ahead and jump into this one right here. All right. Generally, underneath the root directory, we have a directory called home. All right. This is, I'll even say here, this is the home directory. The home directory. It's the only directory in the entire system whose name is home. And it is the parent directory. Parent, okay, well, let's kind of expand our knowledge here about this. I'm going to say that the root directory is the parent of bin. Bin is the child of the root directory. Etc is a child of the root directory, and so on. So anyway, the home directory is the parent of all of our individual home directories. So for instance, all right, pulling this over here like this. All right, I'm going to pick some names that are short, all right, that I can see over here. All right, so underneath the home directory, for instance, all right, starting at the top, we'll pick Isaac here. I-S-A-A-C. So Isaac has a login named Isaac H, based on his name. So that's his username. Where are we? Over here. And anyway, so his username is Isaac. And also there's a directory underneath the home directory that's called Isaac H. Anyway, Isaac owns this directory, can make other directories and files inside of it. That's his area to work, all on his own. Nobody else can get there except for the administrator, you know, his private little area to work. And we'll pick Brian. All right, so good old Brian is here. Brian, also a nice short little name here, has a directory underneath the home directory, and so on. We'll pick one more. How about Wesley here? We'll put Wesley over here also. And then we'll do a ... All right, Wesley on the end of that. Oops, and I misspelled that. Ding, ding, ding. All right. Wesley, where you at? Yell at me, I guess. That'd be an easy mistake for me to make. I'm probably the first one that's ever made that mistake, right? Yeah, not exactly. All right, Wesley R. Okay. There's that. Okay. Kind of reminds me of Unix, you know, and we'll discover that Unix likes to kind of, when they spell common words, they forget certain letters, you know, like password. Where's the O in there? Well, they didn't make it, you know, so kind of, I guess that's where the second E would have otherwise been in your name then. So, all right, so there's that. Oh, yes, so then we will... ... Okay, so we all have... Now, here's the funny thing. All right. So this is the home directory, and there's only one of those. But the home directory is the directory that contains all of our individual little home directories. And that's kind of, I don't like that we use the same term on both of those. This is the one and only directory named home, and it's the parent of these directories. So this is Isaac's home directory and Brian's home directory and Wesley's home directory, and they reside in the one and only directory named home, if that makes sense. So always listen for the so you'll know whether I'm talking about this directory, or if I say your home directory, then, well, that's going to be one of these, okay? So there's more that we could cover here in the Unix file system, certainly so. These are, the big ones, I guess, so we'll just leave it at that, just to make sure that we don't have any issues with time. We're doing just fine. Okay, so we need to start exploring the file system a little bit. So to be clear, in fact, let's give you some lecture notes. All right. So I'm going to go ahead and do the following here to kind of mark the end of my command line reference, because of course, since I'm using a text editor here on this Word document, I can go back and add more things in over time. But anyway, so now I'm in fact, that's right. Now that I say that, I can even just do it this way, vid2. All right, because I kind of like to be able to, obviously this stuff here was typed on the first class period. And then anyway, I like to put a little marker here so that if I'm looking for a particular concept and I know I covered it on, video 10 or whatever, I can easily find that here in the notes. All right, so here for vid2. And yeah, I'm still going to put my little quick reference updates here inside this Unix command reference. But in terms of definitions and rules and the rest of that, I'm going to put them under the appropriate date. Okay, so how about home directory? Some terms here, file system terms. We'll do it this way. All right, home directory. The directory that the system puts you in when you log in. When you have full, read, write access to everything in that directory. So you can add more directories, you can add files, and so on. That's your private little part of the file system. All right. And, kind of a sister term when we're talking about home directory, we also want to talk about a current directory. All right, so we'll come over here and current directory, also called the current working directory. All right. Is the directory that you reside in at any given moment. So what the heck does that mean? Well, let's let you get those things hammered in, then we'll talk about them. George, is your PC up and ready for you now? Okay. I came in before class early, and it had powered off. So I based on the conversation I had with the IT guys yesterday or Monday, I think that was the problem. Your PC and the one that Jesus is in front of, instead of rebooting every morning at 6 a.m. to just power off. So I'm going to send a note, see if we can make sure that happens, so that I don't have to remember to come over and check it for you then. All right, very good. Okay, everybody got that typed in? The flying fingers seem to have stopped and so on. All right, so what's the difference? So to be clear, back to our picture. All right. So these are our individual home directories. So imagine what we might do here real quick. In fact, all right, we'll just do this. Okay, there's that. And back to the pencil. All right. So I'm just going to kind of leave this one blank, and we can all just pretend, oh, there we go. There's my home directory. So we'll just pretend our names there, I get. All right. So, your home directory is one of these things right here. And well, to be clear, your home directory, the path to your home directory, where it resides in the system, and how on the command line we would express a path to it, it's fixed. It's kind of like over here again. All right. So if I go to C:, and users, and so the users folder in Windows is kind of like the home directory in Windows, in that it contains all of the individual users' home directories. And there's not many here, but here's mine. So here's my home directory underneath the users folder, or my home folder, I guess I should say, underneath the users folder. Anyway, then inside of it, I have all of my stuff. But for instance, if I now click up here, check this out. If I click up here, it kind of shrinks it all back down. And this is the path that we could use to refer to this directory. C:, users, /. Anyway, that's the written path information that I could use, for instance, on a command line to type in the path to my home folder / directory on Windows. All right. Anyway, so over here, this is the home directory, and the home directory resides under the root, and we have our individual home directories over here. And again, the path to the location of your individual home directory is fixed, and you can't change it. If you want it changed, you have to send the administrator a note, that'd be me, and then I could make whatever change, if necessary. If you wanted to make a last minute change to your username or something like that, we certainly could do that. But anyway, it's not anything that you could do on your own. On the other hand, the current directory, hey, you can change it all day long by just moving around the file system. Now, permissions will keep you from going to certain places, like your peers' home directories, but you can navigate around and look around a fair amount of the file system just by moving around. It's a piece of cake. It's easy to do so. So these two concepts are kind of easy to remember because it's similar to, in the real world, all of us have a home address. Your home address, and it is, within kind of like your home directory. It can be changed, but it's difficult to do so. Your home address, it's pretty difficult to change. I don't know about you guys. Y'all probably still have many moves left in y'all's lives. Me personally, I hope I'm done moving at this point, except for maybe the pine box at some point, because moving is a pain in the neck. I've accumulated lots of stuff, and I don't want to have to go through all that right now. So we all have a home address, which is difficult to change. On the other hand, all of us also have a current location. And so just think about your current location versus your home location. They're two separate things. One of them is easy to change. I can change my current location by walking across the street, but to change my home's location, a big pain in the neck. So same thing on the server. Home directory, that's kind of baked into the system. It takes an administrator to modify it. Your current directory, hey, you can look around the file system, move around the file system with no problem, as long as permissions allow. We'll talk more about that as we go. All right, let's give you another command to allow you to start to look around a little bit. This will be a good one here. How about PWD? To display the current work, or your current working directory, we'll say. And in fact, PWD, I've heard it explained a couple of different ways. PWD, it will display your current working directory. Well, your present working directory. I'm presently here, I'm currently here, so it will display your present working directory as a synonym for your current working directory. I've also had it explained all those years ago. Someone said that they thought it stood for print your working directory. Print your working directory. Print? What the heck? Where's the printer at? I don't even see a printer in this. We got to go back and do a little history here again real quick. We mentioned this yesterday. We're talking about it again. So, all right, so here we go. All right, everybody here, be nice and solemn as we look at the fathers of Unix and see, all right, here they are in front of an old console, that paper console that we talked about. And so the commands that they would type then would be printed out on the paper, and then the computer would execute the command, and then the output from the command would be printed on the paper. So our computer programming forefathers, when the computer displayed information to them, it was fairly common for the information to be displayed to those old guys, not on something like this or a CRT, but instead by it getting printed. And here we are 70 years later, and when not 70, well, from the earliest days, I guess we're 70 years later. This would have been 1970, so we're 55 years later. And anyway, the same terminology has just stuck. Computer programmers got used to thinking, hey, when my computer displays something, it's printing it. Now, back originally, it meant on a printer. But then, hey, eventually they got rid of the printers and they brought in terminals, monitors, or whatever. But all of the programs and all the vocabulary was already set, so they continued to say we're printing something even when it's being displayed to the screen. So remember that. In computer programming, a lot of times when you say print something, unless I say, hey, print this file to the printer out in the hall or whatever, unless it's something like that where it's very clear, in programming languages and terminology and so on, when we refer to printing something, we often mean display it to the screen. In fact, in Java, if we want to display the contents of a variable, we're going to invoke a line of code that says system.out.print or system.out.println, for instance, okay? So and it's just a historical, you have to look at the history, going back to that picture there, for that to make sense. All right, print your current working directory. So, in fact, everybody come over here, back to the old server, PWD. Hey, looky here. All right, looky here. So I typed in a command, and I hit enter, and the command gave me back this as its answer. It printed, if you will, to my terminal here. It printed that back as my answer to tell me where I am. I wondered, where the heck am I? I asked the system, and it told me, this is your current working directory. So this, we would say that its answer is in the form of a path or a path name. And so /home/usenik. What does that mean? Well, to our picture we go, and then here, and we move this over to the side. We're gonna go ahead and write you some notes about this in just a second, but while we've got this pulled up. All right, looking at the answer that the server gave me, /, that's this up here. So in that path information, we start up here at the root. The slash that this path name contained corresponds to the root directory. So /home, that gets me here. And then the next slash is kind of a separator between the home directory and my directory, which, oh yes, that's me over here in the circle that's not written, and that's me. It's not you guys, that's actually me. No, well, we'll pretend that. So anyway, /home/ and then anyway, your username down here then, okay? So sometimes we give path information to the server. Sometimes the server gives path information to us. It's kind of depending, all right? So with the pwd command, it's giving us information back. And we would say that this information that it gave us is, quote, a full path. What does that mean? Okay, let's back to our notes. So kind of related to file system terms and so on. All right, full path. When written, or typed, of course, it begins with a /. The search for anything specified with a full path starts at the root. All right. When written, yeah, okay, that's correct. All right. Okay, I'm going to be lazy here. Control-C, Control-V, and I'm going to change this to relative path. So, all right, don't get too far ahead of me if you're writing from scratch or whatever here. If you can't make changes, I obviously need to change the definition too. It begins with anything other than a /, and the search for anything specified with a relative path starts at the current working directory. All right. So full path or relative path. I think that we got some good definitions down here now. That's going to kind of help us out as we go forward. All right. So let's see here. Let me ask you guys a question. All right. So I typed PWD and the system gave me this answer. Was this a full path or a relative path? The answer that it gave me? Full path, and how do we know that? Started with a /. Exactly right. All right. So it's kind of funny. Full path, it has to have this one specific little detail. And if it has it, it's a full path. Anything else, it's a relative path. All right. Okay, so there's that. So armed with our definition of full path and relative path and home and current directory and so on, let's start navigating the file system a little more now. Okay, so let's see here. Let's, we need to give you another command. All right. So we saw earlier when I opened up that command window in Microsoft Windows, and I could type dir to list the directory contents. And Unix does not, but Linux actually does provide a command called dir, I guess, for the poor hapless, student that was kind of sort of used to working on Windows, and just to give him a crutch, they gave him a dir command. But real Unix does not have a dir command, so I got rid of the dir command on our Linux server also, because dadgummit, we want to look like we know what we're doing. One of these days you're going to show up at an employer and be working with someone maybe that has more experience than you and so on. You want to use the right vocabulary and type the right commands and look like you know what you're doing and so on. And so I always joke, that before I just went ahead and just removed the darn things, I told my students, don't use dir. because that's the same thing as saying duh in terms of how knowledgeable you look. You know, you don't want to blurt out duh at the wrong time. You know, makes you look silly then. All right, so what happened there? The way to list the contents of a directory on Unix is not the dir command, it is the ls command. All right, ls. Now, with my font here on Word, the L and the 1 look very similar. Even on our command line, they tend to look pretty similar and so on. But anyway, this is called ls. And as I mentioned with Wesley, it's kind of strange. Now, the thing is, again, we can see, here we are 50 years later, and we still can kind of see back in time and picture these old hippies that were working together at AT&T Bell Labs, creating the Unix operating system. And it was something they were doing unofficially on the side. Now, we can talk about history for just a second. There was a big project that was with AT&T Bell Labs and MIT and GE, and they were all working together on this big operating system called Multics. But eventually they pulled the plug, and it was going to go down the tubes, and that was going to be the end of it. But Ken Thompson, one of those guys I showed you the picture of, he wanted to continue to work on it. And the silly reason is, among others, one reason he wanted to continue to work on it is because he had written a fun little game that was on that server. They wanted to continue to be able to develop and play and so on, you know. So anyway, he went to one of the bosses and said, hey, we've got this little cast-off leftover machine back there in the corner of the lab. We're not doing anything with it now. Can I have that for my use, just on my own time, to continue to kick the tires on this operating system called Unix? And here, let me go to our notes here real quick. And this is no lie. So that here's some Unix history. Just a piece of trivia. Well, the operating system that they were working on with MIT and GE and Bell Labs was called Multics. All right, Multics. And after they canned that thing, and Ken Thompson took it over just kind of on his own, just for the fun of it, really just kind of for a joke. Well, Multics, the word many, all right? So Multics was going to do lots of things for lots of people. It was going to be this huge, very powerful operating system. It was going to do lots of stuff. And literally for just kind of to be silly, Ken Thompson said, well, now that it's just me working on this thing here, probably need to scale it back a little bit. So instead of it doing multiple things, I'll be happy if it just does one thing at a time, like maybe play my computer game. So he renamed it to Unix, spelled like that, okay? And it was a joke. It was a joke. It was a play off of the word Multics. But when he took it over, he downsized it from multi to uni and called it Unix. And then later on, they decided to change the spelling to Unix as such. So anyway, so there's that. But anyway, so as he got a little bit of work done on it, and it got interest of his co-workers, and they started saying, hey, give me an account on that system. I want to be able to work on it also. And then more people started working on it and so on. But it was very ad hoc. They weren't even getting paid to do it. Certainly management wasn't guiding their efforts. It was just a bunch of programmers playing around. All right. And so they just decided, okay, I'm going to work on the file system. You need to work on a text editor. You're going to work on a compiler. And they all just dumped all their stuff together, and off it went. And anyway, and so it just doesn't look as polished in terms of consistency, for instance, in how they name their commands and the syntax of the commands and so on, you know. And you kind of see that, but by some of the commands are words, and other commands are, well, ls is hardly a word, you know, it's just 2 letters. And the other thing is, it's kind of weird that this is one way that you can show that you're a guru and not a newbie, is pronouncing the commands correctly. And so, you know, for, let's see, I'm trying to think, you know, certainly we pronounce this as the password command. We don't call out the letters, we call it, you know, we just recognize, well, it's the password command. And anyway, this is the W command and so on. But anyway, ls is short for list. List the contents of a directory, for the most part. You can also use it to give some information about files, but for now we're just going to say list the contents of a directory. But we don't call it the list command. Yeah, they shorted out a couple of letters. We don't just, you know, like with the password command, we don't pronounce it you know, I don't know, somehow pronounce it without the O and the R. We pronounce it as if it's password. But with the ls command, you don't pronounce it list, you pronounce it ls. You call out the letters. Isn't that bizarre? And that wasn't me that decided that. It was all those old guys all those years ago, but that just stuck. It was just very weird. It's just very ad hoc. They threw all this stuff together. But it got extremely popular, started spreading like wildfire. And anyway, and everything was just kind of locked in time. And they've never bothered to say, we need to come back, kind of clean things up. So there's just some funny little things I guess you'll observe about it. All right, so let's use the ls command then. All right, so back over here we go. Oh, here's another little command. If I want to kind of clean up the clutter on the screen and move the cursor to the top, hey, we can even put it in our little command reference, I guess. Here's another one to add to our ever-growing list. Clear, to clear the screen. And move the cursor to the top. Can be kind of handy just to kind of get rid of the clutter. Clear. All right. So PWD, all right, that's where I am. That's where I am. So here's the thing. You know, in Windows, if I, oops, oh yeah, that's okay. Come on now. There we go. Okay, so if I click on C:, so in Windows, if I want to see what is in this directory, I double click it to open it, and then this file browser automatically draws me a picture of what's there. I click on it, and then it draws me a picture of what's in the user's directory. Oh yeah, here's my home directory, if you will, and then I'm going to double click on it, and it's going to draw a picture again. Well, that's a nice thing about the graphical environment. It kind of shows you pictures of where you are as you navigate the file system. But that's one thing about the old command line. Working on the command line, there's no picture. The picture needs to be in your mind. Okay, so that's kind of why I drew this picture here. So we had at least a basic understanding of where our home directories are, how to get to them, and how they relate to other common directories and so on. So we have to have this picture in our mind. Okay, all right. So a handy thing to do if you're working from the command line, if you're wanting to play around with the file system, so on, is make sure, where am I? Okay, /home/ your username. You're in your home directory, and if you type ls, then it lists the contents by default. By default, the ls command will list the contents of your current directory. Oh, let me give you some detailed information about the ls command. All right. The detailed syntax, if you will, or we'll just say the syntax of the ls command, because we're going to learn from this in doing so. So again, this is kind of what I would suggest you do perhaps, is just have this quick reference that has nothing but the name of the command and what it does. And then if you want to put more information about it, more details, I'd suggest you put those in a different section, or otherwise this is going to end up being all cluttered up and so on. But what you could do, for instance, would be, if you're going to add more details on vid2. So now we know where to look. Okay, now we know where to look for more information about the ls command. But let me show you something. All right, ls. There is the syntax for the ls command. We're gonna be referring to syntax for commands and the syntax for statements in our programming languages and so on, using a similar manner as we're doing right here. All right, so I'm not going to bother to type it in myself, but you either need to memorize it or perhaps type it into your notes or write it into your notes. That uppercase word, it seems like we even talked about something like that on Monday, but I don't remember for sure what it is. But to be clear, that uppercase word dir path there is telling you that you need to replace dir path with a path to a directory. You need to replace dir path with a path to a directory. But notice that it's in square brackets. The square brackets tell us that, oh, that thing that's in the square brackets, it's optional. Okay? So you need to understand those two things. The uppercase word, you need to replace that with something that uppercase word is describing for you, a path to a directory. Oh, but since it's in square brackets, it is optional. You don't actually have to supply a dir path, but you can. Okay? So like over here, I typed ls. Did I tell ls where to list the contents? What directory to list the contents of? No, I just typed ls and hit enter. So by default, the ls command listed the contents of my current directory. Now, is your output like mine? You probably have less stuff here, don't you? Yeah, well, because you probably have a directory called PF1, and that's it. Well, of course, I teach PF1 and PF2 and Unix, and I have other directories here, and that's why. Because I'm listing the contents of my directory, and you're listing the contents of your directory. But one thing that's kind of aggravating is with just ls, you can't tell, are these things files or directories? I told you that you have a directory called PF1, but how can I tell by looking at this? Well, you really can't. But check this out. Oh, back to our notes. In fact, oops, if you're writing in pencil, I'll apologize. I'm going to insert one more thing here. Oh. And if you want to stick it at the far end, that's fine also then. So I'm going to squeeze in. You can supply some options, some flags, if you will, to modify the behavior of ls. And again, in your notes, if you want to actually type in these examples in your notes, that might be a perfectly fine example. I guide you. I think I do a reasonable job of guiding you of the minimum amount of notes you want to type in. But you might also, right here, type in some of the examples that we're going to type on the server just so you'll have those as reference. But for instance, ls minus L. And look at the difference between the output I got just now versus what I got a minute ago. If you note, the ls command in Linux lists the contents of a directory. Oh yeah, look at that, alphabetically. We note that, A, B, E, then on to P and so on. So that's alphabetical. But notice over here, hey, go away. All right, over here, it's the exact same things. The exact same things. But L stands for long listing. Give me the more detailed information. Give me the long ls output. Don't just list what's there. Tell me a little bit about everything that's there. So something called ADM. And it was last modified on July the 20th at 2:19 p.m. And bin was last modified on July 27th at 6 o'clock in the morning and so on. And then all the way over here, the very first column, you see all these D's? D stands for directory. Okay, so that's kind of the bottom line. You know, it tells you the owner and the group and the size and the modification time and then the name of the particular thing, whether it's a file or directory. But for the most part, for now, what we're most interested in is, okay, this thing here is, because this D, it's a directory. The rest of this stuff is permissions, and we won't bother with it for now at least. But so anyway, so there's that. So here I supplied minus L was an option. Let's use the ls command to look somewhere else. In fact, I want to look and see what is, how are we doing on time? It's time for a break. In fact, we'll just go and take a quick break. Let's take 5 minutes. We'll come back. We'll pick up right where we left off. All right, we are back. Okay, let's see what we're doing on the server here last. All right, ls minus L. Oh, yeah, that's right. Let's start looking around the file system a little bit. I want to see what's up underneath the root directory. Now, I could move to the root directory and look around, or I can stay where I am. See, check this out. ls/. So I'm supplying some path information along with the ls command. I'm supplying a dir path, if you will, or a path to a directory. Hey, this path to a directory, is that a full path or a relative path? That's a full path. It starts with a slash. It ends with that same slash, but yeah, it is a full path. So according to our notes, since it was specified with a full path, the search for that thing starts at the root. All right, so I want to know what is up under slash. That takes us to the root, and we stop right there. So we're going to ask the ls command to list the contents of the root. And anyway, there we go. So it has quite a few things here, including, hey, looky here, bin, and Etsy, and home, and some others. Well, are they files or directories? Well, we can throw in that minus L option, ls minus L, the root. And we see that, hey, looky there. So we've got some examples of a few different things here. Lots of directories. See all the D's over here. Most of the things are directories. Notice the dash here. So this thing here is a file. This is a file. We also have some things with an L. Those are kind of unusual. What the heck is an L? It's kind of a special type of file. To get the hint for what it is, this thing here, we have an L. Look at that. These things here, we have L. Look at this and look at this. Now you can't see this from home if you're watching the video because the rest of my home screen on my PC is off the recording area. But for everybody that's here in class, do you see any little arrows over there anywhere on the left-hand side of my screen? The answer is yes. As part of those icons, we see a little arrow here and a little arrow here and a little arrow here. So what are those? What does that mean? CS home, because this little arrow over here, I can drag it over into the recording area. Oops, the little arrow didn't come along with it, rats. But anyway, the little arrow there on those icons tells us that those things are what? Yeah, close. Good guess. Shortcuts. Shortcuts. They reside somewhere else. They physically reside somewhere else, but we're providing a shortcut to it. We're creating a special little file that's kind of connected to this other thing, so we can kind of pretend that this this Edge web browser is on our desktop, and we can pretend that Google Chrome is on our desktop, and we can pretend that Firefox is on our desktop, and we can access them through this shortcut. And anyway, this is kind of the same thing. L stands for symbolic link, and it's the equivalent of a Windows shortcut. And this has been around forever. And when Microsoft stole that from us too then also. When they made the little shortcuts, they used a little arrow. But anyway, it appeared here first, these little shortcuts. Again, so instead of calling it a shortcut, we would call it a symbolic link. That's just trivia. You're not responsible for knowing that. But anyway, just explaining what you're seeing here. So let's look and see, just for the heck of it, ls/bin, a full path to the bin directory that resides underneath the root. And lots of stuff goes zipping by here. And gosh, lots of stuff is obviously here. We know that. It lists it in alphabetical order. And the whole page is full of X's, Y's, and Z's. So lots of output there. Lots of stuff in bin. Lots of stuff there. And anyway, including, we might get lucky and see some of the few commands that we've typed here so far. Let's see, like W, for instance. Are we going to see W or who or something? U, V, got to get my alphabet. Hey, look at there. Oops, I moved. There is W at the bottom of the screen. And anyway, we found one. We found one. So there's that. All right. We could say ls-l/bin to get more information. Oh, look at this in this particular case, now that I look. Hey, looky here. As it turns out, on our server, /bin is actually, all of those things actually reside in user bin, and we use a little shortcut here. But that's trivia. Just we're going to pretend, and it often is, but on this version of Red Hat Linux, bin is actually a shortcut to a directory called user bin, but no big deal. All right, we're doing just fine. Let's see here. Let's start moving around the file system. So back to our notes we go. Back to our notes. CD to change your current working directory. We'll say details on vid2 down here in our notes. So I'm going to come down here and I'm going to say syntax for the cd command. So another command that chop it way the heck down. Of course, there's actually two words kind of moved together, change directory, but you pronounce it by pronouncing the letters, which seems kind of weird. I will admit that, but anyway, that's the way that it is. All right, cd, and then square brackets, dir path. Okay, so let's give you some examples of that then. Now, just for the heck of it, I'm going to do a clear. cd/, enter. And now I'm going to type pwd to verify. Hey, looky there. I was in my home directory. But now, just like we said, it's easy to modify your current working directory. Hard to modify your home directory, but it's easy to modify your current working directory just by using the cd command. That's all it takes. So cd to the root. And then I verified that by typing pwd, and it tells me, hey, you're in the root directory. And now when I type ls, it lists the contents of, I didn't give it a dir path, so it lists the contents of the current directory. My current directory is the root. It's listing the contents of the root, ls-l. Oh yeah, we've seen those things before. So hey, there you go. What if I wanted to go to the, back to our picture. Let's say I wanted to go to the Etsy directory. All right, back to our command line. I'm currently in the root directory, cd to, hey, let's do this a little differently. Well, we'll do this one this way, etc. My question for you, is that a full path or a relative path? Full? So when I asked the cd command to take me to the /etc directory, it said, okay, I'm going to start looking for this thing up at the root. Oh, here it is, /etc, and it cd'd me. It's changed my working directory to right here. And now I am in the etc directory. And if I type ls here, it's going to give me a whole bunch of stuff to go flying by. In fact, I might not even bother. But anyway, the etc directory, also lots of config files and so on. Oh, what the heck. There they all go. Oh, there we are. Listed those actually in 3 columns. There's quite a few of those things there. Let's go back to the root. cd to the root. Let's do the same kind of thing, but maybe we'll go to the home directory, but using, for the first time ever, I think, a relative path. All right. So what the heck, pwd, oops, excuse me, clear, pwd. All right, so I'm in the root directory, and I want to go to the home directory. cd home. Is that a full path or a relative path? Relative, because it doesn't have a slash. So the search for anything specified with a relative path starts where? It's in your notes. Current working directory. That's exactly right. So I'm in the root directory. I just verified that with the pwd command. I'm in the root directory. In other words, you have to have this picture in your mind. I'm up here. And I expressed a relative path to something called home. Oh, that's okay. I'm good because I've got a home directory right here. So I hit enter with that relative path. Hey, sure enough, I verify. I ask where I am. I'm in /home. Looks very good. All right. So looks pretty good. And all right, but it depends on where you are if you use relative paths. Like earlier, I did a cd into the etc directory. What if I say cd to etc here? That's a relative path. It's going to look for a directory called etc in my current directory, which is home. Maybe one exists. Maybe I have a user called etc. Maybe maybe that exists, or maybe not. It doesn't in this case. So if I'm in the home directory, cd to etc with a relative path doesn't work. If I'm in the root directory, cd to etc with a relative path does work. Okay, starting to kind of get the difference there. So, full path, doesn't matter where you are, because that's really not involved, It just starts at the root and navigates down to where it needs to go. But, so full paths will always work. The truth is, they could have created Unix where you have to use a full path all the time. But then even if you're just wanting to look at a file that's right there in my current directory, you'd still have to express a full path to it. That'd just be a lot of typing. So they just created this relative path thing just to save you some typing. So, okay, if something's kind of close to where you are right now and you want to refer to it for whatever reason, you want to remove it or print it or edit it or whatever, well, you can use a relative path if it's convenient. If not, you can use a full path, and they both ultimately always work, but one will be more convenient than the other at any given time. Okay, let's see here. We're doing just fine on time. We've got, gosh, almost an hour, believe it or not. And I want to get to the point where we can give you an assignment to do over the weekend then, okay? So we're gonna push on here. So let's see what I want to do. What the heck? Let's just go ahead and do so. I'm gonna move this up. All right. And okay. So here's what I want to do. So in your mind, unless you're Isaac or Brian or Wesley, then pretend that you're right here. And I'm going to do the same thing. Oh, this is my home directory right here. Okay. And what I'm going to show you is how to make your own directories as a little exercise. So we're going to do the following. This doesn't exist yet, but we're going to make it. A, B, C. So we're going to make that the case. All right. So I'm going to show you how. We'll move this over here. So we would like, underneath our home directory, for there to be a directory called A, and underneath A there's a directory called B, and underneath B there's a directory called C, and so on. So, to create a directory, oh my goodness, back to the command reference, yet another command. All right, back up here we go. And again, this is just kind of a description, then the details will be down below. That looks like I misspelled details earlier. Okay, so let's say, make dir. All right, details. We'll spell this one with an E on vid2. And I'll go ahead and correct this with an E also. I'll blame that on my keyboard, I guess. Details, there we go. All right, and again, it's kind of bizarre. You just have to kind of get used to it. We call that the makedir command. Makedir. You know, it would be just about as easy to say, and they could have decided, somebody back when could have decided, oh, that's the mkdir command, you know, would have been appropriate perhaps, you know, but anyway, that's the makedir command. So sometimes, even though it's a pair of letters, you pronounce it as a word, and sometimes you don't. And it's pretty random. Yes, I will admit that, you know, but, all right, so there's that. Let's show you the syntax. Oh, syntax, let's see here. Syntax for the makedir command. All right. Dir. I get dyslexic in my typing these days. There we go. So look at the difference in the syntax between the cd command and the makedir command. So here, dir path, you have to supply a path to a directory. Here, what does it mean if it's in square brackets? Optional. How does it make sense that the cd command, you're trying to tell it to take you somewhere else, but you don't have to tell it where you want it to take you? It's going to read your mind. That's an advanced feature of Unix, I guess. Well, okay, if you're like me, you're currently in the etc directory. So, you know, if you're not, you might go to there, just go to the root directory or whatever. And now, through trial and error, according to the syntax over here, it appears to be the case that you can execute the cd command and not tell it where you want to go. And it will do something. So just by trial and error, you do it, type pwd when you're done and see where it takes you. Where will the cd command take you, or will it just display an error, if you don't tell it where you want to go? Just type cd and hit enter. And then type pwd and hit enter. So you can see where does it take you when you execute the cd command, but you forget or intentionally don't tell it where you want to go.
It takes you to the home.
Takes you to your home directory. Okay, isn't that kind of bizarre? You know, I don't know, maybe that was a little token nod towards the beginning user. Oh, poor little Bobby forgot to tell us where he wanted to go. We'll just take him home. Maybe someone will want him there. All right, so cd, and now I'm in my home directory. All right, so sure enough, the cd command, you don't actually have to tell it where you want to go. It'll take you home if you forget. All right, but the makedir command, you must tell it the name of a directory to create. All right, so all right, make sure you're in your home directory. So cd to home, and then verify that with a pwd. Makedir a, enter. See, if you just type makedir and you don't give it the name of the directory to create, it's going to give you an error message and it doesn't do anything. All right, missing operand. So, but makedir a. Now I typed makedir a, I hit enter, and I just got another command prompt. I didn't get any output from the command. Some commands generate output, some commands don't, and you know, but instead they actually are just doing something under the covers, if you will. And for those commands, generally, no news is good news. If it didn't work, it'll tell you. If it did work, it's silent. And that's the case here. Makedir a, and it didn't complain. ls minus l, oops, ls minus l. Hey, look at that. Look at that. Got brand new right now. I got a brand new directory called A. All right. Hey, tell you what let's do. pwd, verify where I am. I'm going to go into directory A, cd to A, with a nice little relative path. pwd to verify where I am. And now again, what I'm wanting to do is to create this little directory tree here with A, B, and C. So I'm in directory A. Again, look at that output from pwd. Makedir B. ls minus l. Look at there. I got a brand new directory called B inside my current directory, which is A, which is underneath my home directory. Looking pretty good. CD to B. pwd to verify where you are. I'm under my home directory /A/B. Makedir C. All right, looks pretty good. All right. And so their relative paths were real convenient. Just I want these directories to appear right underneath the directory where I currently am, and then I cd into those directories, and then I make another directory, and so on. Very, very, very convenient. You know, to make dir C, could I have done this? Makedir /home /my username /A/B/C. Could I have done that instead? I could. I could. you know, this is the path to this directory called C /home / my username /a /b /c. Yes, this absolutely would have worked, but it would be more work. So again, you just pick relative path, full path, whichever is more convenient based on what's going on at that time. Now, I've already made a directory called C. Now, I was thinking about just aborting by typing to our notes. To our notes. This isn't really a command, but it's still something that's probably pretty important to remember. Where do we want to stick it? Oh, we'll put it down here to the bottom. All right. To interrupt a running program or abort the composition of a command. Command line. Composition of a command or command line. So we'll just put this down here at the very bottom underneath all of our commands. It's kind of important. It's, you know, Control C. Now this is how we write. You know, if I was to write it on the board, or if I was to, you know, want to type it into Word here or something like that, I typed this here with a Shift 6 and then a C. But to be clear, that's how I would type it into some text just to show you to refer to Control C. But how do I type Control C? I hold down the Control key and then I hit the C. Now it's funny, every once in a while, in fact I just saw this just last semester, that I had a student that thought you had to hold them both down at the exact same time, the Control and the C at the same time. But to be clear, you want the Control key to be down first. It's kind of like, how do you type a capital C? Hold down the Shift key, hit the C key, and then let up the Shift key, right? It's the same thing. For Control C, Control, hold it, C, and then let up on the Control. But how you would write that into Word, you know, if I typed Control C, those two characters, then it wouldn't display as such. So this is how we commonly represent Control C, Control D, Control Z, various control sequences, and so on. So anyway, so over here, if I typed Control C here, it would abort. It wouldn't execute the command, but it would actually leave it here. So that's an alternative to backspacing it off of the command line. In fact, I'll just even do it real quick. Control C. That aborted the composition of this command line. It did not execute that command line. It aborted. So if I type it again, and now if I hit Enter, it's going to try to create that directory. But that directory already exists. Okay? So anyway, that kind of verifies. I was inside of directory B, and I used a relative path to create directory C. Look at our picture over here. And that worked just fine. It did create that directory. I didn't bother to type ls to verify here, but it did create directory C. And I verified that doing this little relative path from inside directory B is an equivalent to typing a full path to directory C. One's more convenient than the other. And the fact that it said, nope, can't make that directory because it already exists, confirms that those were equivalent commands, if you will. All right. So now what the heck, just to verify, ls minus L, hey, looky there. I've got directory C inside of directory B, which is under directory A, which is under my home directory, and so on. I want to practice moving down the file system. In order to do that, I'm going to move up to the very top. In fact, clear, CD to the root, PWD, okay, we're at the root. And we're going to practice using relative paths to move down the file system. All right, so again, in no time at all, not that this is especially complicated, of course, you got the root, you got home, and then your individual home directory, and then whatever you've put underneath it, of course, right? So, all right, so I'm gonna slowly move down the file system using relative paths. I'm in the root directory, CD to home, PWD to verify where I am, all right? That looks good. And to type ls, we've got a fair amount of, well, I could just type ls without ls minus L, just to make the output a little shorter. I'm going to type just ls. Okay, so I'm in /home. I'm in this directory right here. I'm in the home directory. And I see, oh, yeah, here I am. So this is me, of course. You'll find your own little username over here, of course. And I want to move to my home directory using a nice relative path again. CD to my home directory, PWD to verify where I am, and then find that in the picture at the same time. Okay. And then, all right, one directory at a time. I'm going to keep going down. CD to A. PWD to verify where I am. And then I want to look around ls minus L. this little sequence here, CD, PWD, LS, this is kind of the equivalent of what that File Explorer on Windows does for us. You know, we click on a folder, it CDs us into that folder, and then it displays the contents, but we have to do it with a sequence of commands. We have to CD and then do a PWD to verify where we are. That would be displayed at the top of our File Explorer, and then LS-L to get the contents again. Let me just pull this up here real quick. You know, users. So users is display. Here's the PWD. See, here's the PWD information, and here's the LS-L information. And then I click on another folder. Oh, here's the PWD information, and here's the LS-L information. So we have to do it one at a time. Again, certain things, no doubt, you know, looking around, just exploring around casually. Doing it from a graphical environment's easier, certainly is. But the power tasks that need to be done are more than just poking around the file system, you know. And for that, ultimately, the command line wins out. All right, so I'm in directory A. And I see that there's directory B there, CD to B, PWD to verify where I am. Oh yeah, so I'm down in this directory right here, LS-L to take a look. And I see there's a directory C there. Okay, CD to C, PWD to verify where I am, LS-L, nothing there. This total 0, that throws in that when you use the -L option. If you just use LS by itself, it doesn't bother. But -L will tell you the number of disk blocks that are consumed in that directory, which in this case is none. All right, so I'm down as far as you can go. I can't go any further. How do I know you can't go any further? Because there's no directories underneath me, all right? So we just, my friends, we just went from the root down to directory C, one directory at a time. One directory at a time using relative paths, all right? But what if we want to move up one directory? Well, so what directory are we in? C. If I want to move up to directory B, it's right there. It's right above me. CD to B. So, you know, relative paths look below where you are. Look below where we are. Darlene, did I hear you over here? Very good. Very, very good. Another option to the LS command. Another option to the LS command. LS shows us nothing. LS-L still shows us nothing. But the amazing thing is, there's another option that you can supply to LS. LS-A. A stands for all. Show me absolutely everything that's in this directory. By default, it's kind of a weird thing. By default, some files and directories are kind of swept under the rug and they don't show up by default when you use the LS command. And it's by design. It's just because sometimes there's a lot of clutter in a directory, and if you want to, you can sweep things under the rug where they don't show up normally when you type LS. It's not a security thing. They're not more secure or anything else like that. It's just that they don't clutter up the output of an LS command. Our home directory has a fair amount of stuff that's swept under the rug there that we don't see normally. But if you want to see it, you can supply the -A option. So sure enough, A for all. You know, L is for long, A is for all. So even though we thought this directory was empty, there's actually something or two somethings that are here. I see a dot and a space or two, and then a couple more dots. Hey, let's combine some options. LS-A-L. Or in fact, we could type LS-AL would be fine too.
Like combine.
You can combine them, that's right, just like this. Oh, so we're getting more information. So sure enough, we saw this output here, we wondered what it was. Now we see dot and dot dot, so it's just simpler. Computer people call them dots instead of periods just because it's a shorter word. And we see there's something called dot, which is a directory, and there's something called dot dot, which is a directory. That's kind of weird. Okay, well, we saw just a minute ago how convenient it was to go down, 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 down using relative paths. How can we go up with relative paths? We just discovered it. So we're going to talk more about this on Wednesday next when we come back after the Labor Day break. So dot is a relative path to the current directory. Now, we don't need it today. For instance, if I was to say ls space dot, that lists the contents of the current directory. cd space dot, that CDs me to the current directory. Well, the dots weren't really helpful there, and we didn't really need them. Okay, they were optional. We didn't need to put them in. Dot dot, on the other hand, so dot is a path, a relative path. It's not full. It's a relative path to the current directory. As Darlene said, ding, 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 good job there, Darlene said, dot dot is a relative path to the parent directory. So I'm going to remain in directory C, for instance, ls dot dot. So I'm just looking. I'm not CDing up there. I'm just looking up there. And what does my parent directory have in it? So this is kind of weird. ls dot dot. And so I'm in directory C. I list the contents of B. What does B contain in it? C. Isn't that weird? You know, directory B contains C. So here I'm in directory C listing the contents of the directory above, listing the contents of B, and I see that directory C is there. ls dot dot, oh my goodness, slash dot dot. All right, this dot dot, that gets us to B. This gets us to A. And what does A contain in it? B. Slash dot dot again. This gets me to B, A. This lists the contents, oh my goodness, of my home directory. So you can express a path using relative paths going up from directory C, up 1, 2, or 3 directories going up the other direction by using the old dot dot. Because directory C has a dot dot, directory B has a dot dot, directory A has a dot dot, they all do. And look at that. So even though I'm in directory C, I can express a relative path to a parent directory just by using the appropriate number of dot dots. Isn't that weird? Okay. Pretty cool. Hey, one other thing, and then we're going to start giving you your assignment. 9 o'clock until, that's right, 9 till 11:15. My summer schedule was off. My classes started at 9:30. I wanted to make sure I wasn't thinking wrong. But this is from 9 till 11:15. Gosh, we're doing just fine on time then. Okay, so looks pretty good. Hey, one other thing, and then I'm going to switch gears to our assignment. But one other little detail. I'm going to go into our picture here real quick. I'm going to make one more little change. All right. What's that little character? I did a poor job of drawing, but anyway, some of y'all will know.
Squiggly line.
With a squiggly line, yeah. That's good enough for me, but there's, I think, maybe an even more official name than that. A tilde. A tilde. You know, look at the upper left-hand key underneath the escape key. So it's the shift of the back tick, all right, the backslash there, not the backslash, excuse me, the back tick. So that's the tilde. And anyway, the tilde is a special character to bash. Tilde is a special character to bash. Oh, we'll put our notes in here. We're doing just fine on time. All right. Tilde is a special character to bash. By itself, tilde will be replaced with a full path to your home directory. Okay. So for instance, I'm down here in directory C, but if I type ls tilde, all right. So this is kind of, here we are on day 2. Things are already getting a tiny bit more complicated. You know, if I ask you if that's a full path or a relative path, everybody would blurt out relative because I don't see a slash there. But the funny thing is, it will be replaced with a D. All right. So I hit enter and bash the program that's reading in my command line here. It's going to read this in, and when it sees that tilde, it says, whoa, 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 whoa. This tilde is a special character here. And so bash is going to replace that tilde, it says here on my Word document, with the full path to my home directory. And then it's going to pass that full path to my home directory to the ls command. So what the ls command actually receives is the full path to my home directory, and then it's going to do its thing. See, I'm in directory C down here at the bottom, and this allowed me to list the contents of my home directory. And although it didn't look like a full path, well, it had the effect of a full path after bash did its magic. So bash replaced the tilde with /home/my username and then passed /home/username, that string of characters, to the ls command. And the ls command said, oh, he wants me to list the contents of /home/my username, and did its thing. Isn't that weird? You know, so you can do the same thing. ls tilde slash a. Oh, it's going to list the contents of directory A that's underneath slash home slash my username. So the tilde, the slash A just gets appended to my full path after bash has replaced the tilde with the full path to my home directory. And that works also. Yep, sure enough, directory A contains directory B. We kind of verified that. Kind of cool. And all right, so that way, that was another little detail I could draw here. Hey, this is the path to my home directory, if you will, or this is my home directory. But we give you a little more notes here. All right, and we'll be replaced with, okay, if the tilde is followed by a username, then bash will replace the tilde username. All right, so fill in an actual username there instead of, USERNAME with the full path to username's home directory. Okay. Now we need to put that down below, perhaps. It's kind of the opposite of what we're looking at above. Okay. So on the server, I have a couple of pseudo accounts. They're kind of bogus accounts that I've created for my own use for various little things. I have an account called Mark, my first name. And again, my official fictitious name that I use sometimes is Bob. It's a nice short little name. It's symmetric. I like Bob. So anyway, so there's a Bob account. So for instance, ls tilde Bob. Oops, Bob. So in this case, since the tilde is followed by a username, bash is going to replace tilde Bob with the full path to Bob's home directory, which is slash home slash Bob. And then the ls command is going to take a peek into Bob's home directory, and it sees, oh, sure enough, we've got a handful of things there. Okay. So tilde and tilde username. That's been around in Unix forever. And now I want to pull something up here real quick and have you look at it. I pulled up a web page. Look at the URL. What do you see before my username? A tilde. So in other words, web servers. All right, so the web browser is going to send this string of text to the web server. All right, it's going to send tilde usenix slash ac.html to the server cs.actx.edu, which is sitting down at the end of the hall. And the web server is going to take that tilde usenix and replace it with the full path to my public HTML directory, which is underneath, I don't want to expose my entire home directory to the internet. I only want to expose what I want to. So inside of my home directory, I have a directory called public HTML. And so when we pull up a web browser and say tilde usenix, then the web browser takes you to usenix home directory, and then it kind of adds on its own this public HTML directory. And underneath public HTML is where this file ac.html is. See, it is right here. Okay. So in other words, the internet uses that same tilde notation to refer to a particular user's home directory. Why does the internet, why do web browsers use the same notation that Unix has used for decades before the web browsers came around?
What, they hook to servers as well?
Say that again?
Are they hooked to servers as well?
Yeah, the web browser, the web server is running on a server. That's right.
So would they use similar?
Yeah, they're going to use the same notation. So the web browsers and web servers are going to use the same notation as the underlying operating system and so on that those early web server programs ran on. In other words, we have tilde username on our web browsers because when the web browsers were created, all of the web servers were running Unix. All right, Unix and Linux. And we showed you on operating system market share, we showed you that on Monday. 89% of the world's web servers are Unix and Linux. And anyway, and Unix and Linux kind of had a head start in that regard. The very first web browsers, of course, Windows existed then. See, that was 1995. The first web browser popped up mid-90s. The internet had been around for a couple of decades prior to that, and you could log in remotely, kind of like when we're logging into our server there. You could log in, you could exchange files. There were some simple little message boards and so on, you know. So the internet existed since the late 70s, but the first web browser wasn't created until the mid-90s. But when they created the first web browser, even then, the predominant servers across the globe were Unix. Now Linux was just getting started then. Linus Torvalds was a student at that point getting ready to do a special little project there that became Linux, you know. But anyway, the first web browsers that were created were connected to web server programs that ran on Unix, because Unix was already dominating the world, is the honest truth. So anyway, that's why we see tilde username. It's because that existed on Unix before web browsers were even created. And web browsers and web servers are targeted towards Unix then. So anyway, so there's that.
I would never thought of that.
Neat little piece of trivia there, huh? That's right. Very good, Derek. Okay, so let's get you guys going now. Let's start talking about your assignment. All right, so for your assignment, there's a good little picture. Oh, in fact, that's right. I finally, just last semester, I made this picture big enough where instead of having to erase it, I could just scroll it off the screen here. Your assignment. What you're going to do for your assignment is you're going to navigate to this directory, /user. Good grief, that's sloppier than normal. My writing's bad, but with this darn stylus and a tablet, so it's even worse. User, USR. There's no E in user in the word in Unix. There's no E in the word user. And then underneath that, there's data. That's data. Looks like Clada, but anyway, data. I'll correct that. There you go. Piece of cake. Looks perfect now. Good grief. It hurts to not be able to write correctly. All right. And then underneath that is Unix. So this is a little directory path, a little directory that exists in the system /user/data/Unix. In fact, let me go and open up permissions on the assignment, and we'll pull it up on the old web browser here real quick. All right. cd to pub, and then Unix change mod 011 lab 1. Okay, so we're going to do the following now. Okay, and I'm going to go to PF1 lab, Unix lab 1. So I teach for my CIS students in the CIS area. I teach a class called Unix, just how to use the Unix operating system and so on, and I assign them a number of labs. Anyway, I'm assigning you guys one of the labs that I created for this other course. Makes sense. You're learning Unix. I'm teaching them Unix. So anyway, there's at the very beginning of this class, there's some overlap with that other class in terms of the labs that we do. So here is this assignment. And here's a neater version of the sloppy picture I just tried to draw. /user/data/Unix. It's a full path starting at the root, and I've kind of drawn a picture of it over here. But what you're supposed to do is draw a picture of everything that you find underneath that. Now, to be clear, just to save you a little bit of room on your page. All right, and over here, where's my marker? Here we go. Okay, so here's your page. Boy, that's sloppy. There's your page. And you don't need to draw slash and user and data and so on. So here's the top of your page, in other words. So your assignment for Lab 1, which we're going to have you do over the weekend, take a clean sheet of paper. This is the one and only assignment of all of PF1, 2, and 3 that you'll complete on paper. Or if you want to complete it on a drawing tablet, that's perfectly fine also, okay? Or if you wanted to use whatever drawing tool with a mouse on your PC, that's kind of fine also. You can print it off, or we'll talk about that in just a second. But just to save you a little room on the page, don't even bother to draw this. We recognize that this Unix directory actually resides /user/data/Unix. And all that you need to do for this assignment is just draw a picture of what you see. All right? Just draw a picture of what you see. So let's get you guys started on that task. Okay? So let's do the following. All right. CD. I'm going to go, in fact, let's CD to the user data Unix. PWD. In fact, let's just do the following. PWD. So I'm in /user/data/Unix. To be clear, I just type CD /user/data/Unix. Verify where I am. All right. And this piece of cake, this is a pretty simple little assignment. It will take you, once everything kind of clicks, if you've been doing well with us here in terms of navigating up and down and looking around the file system and so on, you should have no trouble. And all you need to do is just explore and draw what's here. Draw a picture of it, ls minus L. And looky there. I have 3 directories, and look over here to the left, and 3 files. Okay, this is easy. So, all right, kind of armed with that. Okay, armed with that. So I have directories A, B, and C. So I'm going to come to my picture, A. So in our pictures, directories have circles around them, and parent and child are connected with a line. So I have directory A, directory B, and over here, directory C. Okay. But I also have files F, G, and H. Now when I draw a picture, I need to be able to tell the difference between a file and a directory. If I came over here and drew F and drew a circle around it, connected it to Unix, you couldn't tell the difference on my picture between a file and a directory. And again, this is a common notation that books and web pages and so on will use. So these are directories that reside underneath Unix. F, G, and H are files. So I draw those just below and to the right, and I separate them with a comma. F, G, and H are files in the Unix directory. A, B, and C are directories in the Unix directory. Does that make sense? So does that mean that your homework is done? Well, no. Kind of like over, well, oh yeah, kind of like over here. You know, we need to keep going down till you can't go down any further. Remember, we went down to A, and then down to B, and then down to C, and then we looked, and there's nowhere that we couldn't go down any further. So how do you know you can't go down any further? Because there's no more directories underneath you. Well, I know there's directories underneath where I currently am because I'm in the Unix directory, and there's directories A, B, and C. I need to explore those. So let me add one more thing to your notes. Yeah, we're going to be doing a lot of that. That's exactly right, Derek. Okay, hint for Unix Lab 1. Do the following steps over and over and over. All right. Number 1, CD, so we'll do it this way, CD to a new directory. Number 2, PWD to verify where you are. And when I say verify, you know, you'll look at the path information that's provided back, and then you'll look at your picture, and you'll say, okay, in the picture I am right here. The system told me where I am. I'm drawing a picture of all of this. I look at my picture, and I point to the directory where I currently reside. Because you have to know what directory you're in on your picture, so when you find some more stuff, you can add it to the right place in your picture. Does that make sense? All right. You know, I had to know I was in the Unix directory. When I typed PWD, that verified I'm in this Unix directory. I typed ls-l, and I saw these things here, and I drew them in the Unix directory. But now, CD to A, for instance. PWD, oh, that's these steps here. We're not quite done adding them to our notes. CD to a new directory. PWD to verify where you are. Hey, we've done those. What comes next? Derek, you just said it. ls-l, right? To look around in the new directory. And then repeat. Okay? That's how you're going to tackle this lab. So you're going to keep going down until you can't go any further. We'll just add just one more little bit here just to kind of get you started. All right, so just like my notes say, we're going to CD to a new directory, PWD to verify where you are. Okay, we've done those two things. I'm in directory A. That's this directory right here. I'm in this directory right here. PWA just told me that. Now I need to look around. ls-l. All right. I'm not going to bother to draw this on my picture, but I know that directory A, looky here, contains 3 directories and 3 files. So I'll add those, and now I need to go down even further. And you keep going down until you can't go down anymore. Now let's pretend, it's not the case, let's pretend that you couldn't go any further than A. We looked around here, there is nothing, for instance. What am I going to do? Go up and then back down to B and look around there. And when I'm done there, I'm going to go up and then down to C and look around there. You know, and of course I can use those as relative paths. If I'm in directory A and I want to go to B, CD to ... CD to B. Or of course, I could just say cd to dot dot slash b would work. See, check this out. I'm in directory A, cd dot dot, that gets me to Unix, slash b. Oh my goodness, isn't that cool? Okay. So you just have to keep exploring this small little directory tree here until there's nothing left to explore. And to be clear, it's not like it's going to take you all weekend. I don't remember offhand. There's 15 or 20 directories, about the same number of files, so it's not a big deal. We've already got 3 directories and 3 files, so we're whatever 15% done or something like that already. So once it kind of clicks what you're doing, you'll knock it out in 15 minutes. But if you're kind of stumped on getting started, then, well, I don't know how long it's going to take. You might need to replay today's lecture, on video, or come ask me a question or email me a question or whatever. If you wanted to email me a question on this lab, you might, instead of just saying, well, I'm trying to do something that doesn't work, give me some details. I'm in this directory, I type pwd, it shows where I'm in. I'm trying to do this next command and it's failing, and maybe even do the following. See, check this out, guys. Let me show you something that'll be helpful. So let's say that I was trying to get to directory X. All right, pwd cd to X. What the heck? There should be a directory X here or whatever. This doesn't make any sense. So what you can do, for instance, is, all right, pwd, this is where I am. This is what I tried to do. It didn't work. This is kind of neat. When you highlight something in PuTTY, it's automatically in your Windows clipboard. So now you can go to Gmail or whatever and Control-V, paste it into an email message to me, for instance. So give me some context of what's going on if something doesn't work. If you just say the CD command doesn't work, the whatever command doesn't work, I need to see exactly what's going on, and this could be helpful. Where are you? What's the command you're typing? This gives you the where are you and what command are you typing and so on. Then I could look at it. Oh, well, there is no directory X underneath directory B. That's why you got that message, for instance. And so once you highlight it, then you can go to, again, to any Windows program like Gmail or whatever, and you can Control-V, look at that, and just paste it right in there then, okay? Pretty slick. Question, Derek?
So, let's say, like, for instance, that was to happen, and we were stuck. Would we be able to put all in one command line? cd dot dot, then slash X to get to the X if we were stuck in like a situation like that?
Just like we did here, you can say cd dot dot slash something else. We did that very thing right here, for instance, and that did work.
Okay, all in one. Oh,
yes, that's right. Yep. So make sure and just follow, for lab 1, make sure and follow these little hints. cd to a directory, and you might kind of know where you are, but just to be real clear, type pwd, look at it, and again, so you're looking at it. Okay, here's when I look at the result, but then equally important is, okay, it says I'm in directory B underneath the Unix directory. In other words, I'm right here, because this is where I need to keep drawing my picture, in other words. So you have to connect this picture, which normally is going to be in your brain. Windows does it for you, but we don't need that. We don't need that crutch of Windows. We're going to do it on our own. We have the picture in our mind, But for lab 1, we draw the picture out just one time, just to demonstrate mastery of navigating the file system and understanding what you're seeing and drawing a picture of it. Okay. So here's the scoop on lab 1. I'm going to combine my Unix lab 1 and my Unix lab 2, and they're going to count as one grade. So what I've assigned you now is half of that. I'll be real honest with you. It's just half of that grade. And so in fact, I'm going to grade that by coming around to you guys and looking at your pictures on Wednesday morning, the first thing, okay? So if you have it on a tablet or whatever, you don't actually need to try to find a way to print it or whatever. You can just bring it up on your tablet, your notebook, whatever it happens to be, your laptop, whatever it is, and we'll grade it that way. If you do it on pencil and paper, perfectly fine also. But then we're going to cover some more stuff. And I'm going to give you another assignment that's going to depend upon this picture. You want this picture to be correct, or otherwise the second half of the lab you'll have problems with, either difficulty or miss some credit on and so on. So give this easy little lab it's a bit of attention, and if there's any question, double check it and so on, a time or two, and make sure it's correct then. And I'll verify it just by looking at it on Wednesday when we come back. We'll push on from here and we'll start. One other thing we could do just as a little assignment now. Again, we've got officially about 10 minutes. Let's give you one more command. All right. Remove dir, rmdir is how it's spelled. Guess what that is? To remove a directory. Details on vid2. We'll go down here and, okay. And where was our make dir command? Here we go. I'm going to be lazy. Control C, Control V, change this to RM. And every once in a while we'll hear this as RM-dir, but remove dir is also common. All right, RM as such. So you can use the RM-dir command to remove a directory. So let me show you something though. CD to my home directory, ls minus L. Oh yeah, I've got this directory A. I know all about that directory A. It's this directory A right here. That's this directory right here, and I just want to remove it because it's just clutter from this point. It was served its purpose, but we don't need it staying there forever. So rmdir A. Oh man, not empty. Is there a way to remove it? Yes, I'll tell it to you later, perhaps. Okay, but for right now, what's the workaround? Directory A is not empty, but directory C is empty. So remove directory C. And then remove directory B, and then remove directory A. Let's update your notes, and then we're going to finish up. Okay. Do I have something that says homework for today? I do not. So let's do that. Number 1, send me your, quote, lab 0 and IP if you haven't. Number 2 would be to do lab Unix lab 1. We'll go ahead and just do this. And I'll put it right here. Control V. And to help you guys out, I'll make it bigger text, kind of like we did before with lab 0. So I'll bump that up nice and big. There we go. There's that. And then, all right, number 3. Okay. Remove A, B, C directory. Here we'll just even do it this way. Tilde, you guys know what I mean. Tilde /A/B/C directories. Just to get rid of some clutter then. And is that it? I think maybe so. Questions? All right. Are your brains hurting now? Your brain's full? That's right. It's a lot to cover, you know, but a lot of little details. That's what I apologize. Let me just apologize right now. PF1, it's not the most difficult programming class, but it's one thing about it that's kind of tough. There's a million little details that we have to cover. Whether it's programming or learning the development environment, there's just lots of little stuff we have to cover. It's the class I work harder in than any of my other programming classes because there's just lots of little stuff, and I can't just skip it or assume you know it or whatever, you know. And so it kind of makes it tough for you guys. You have to be ready to scribble down those notes and everything else. But hey, if in doubt, replay the video, you know, that I'll post to Blackboard then this afternoon before I go home and rewatch again, make sure you know what's going on. And, you know, one thing, very much like a math class and so on, you know, if I was teaching history, and if you didn't know history of the U.S. During the Civil War, you could still do good on a test on the history of the World War II, for instance, you know, because not knowing one doesn't affect the other. But on the other hand, like in a math class and your programming classes, if you miss one lecture and don't get it made up, that could cause you unknown number of problems in the days to come. Whether it's a math class, programming, lots of technical classes, programming is certainly like that. So I'm begging you guys, if you miss a class or if you're just fuzzy on something, go back, watch the video, send me questions, do whatever it takes to get caught up. The kiss of death in classes like this, math classes, computer classes, or whatever, you know, if you just didn't get factoring, I didn't understand factoring in algebra, oh well, I'll figure it out later. That's the kiss of death, all right? If you don't figure it out ASAP, you're doomed. And we recognize that as math students in this class. It's the same thing. Everything that I've stripped this class down to the bone, and everything I cover is critical, and if you don't get it, you're going to have trouble from here on. So please make sure and to stay caught up, whether it's watching those videos, contacting me through email, stopping by, or whatever, because I want every one of you guys to come back here in PF2 and 3 and knock these classes out. And I want to help you do it, but that's how you can help me help you to do that, okay, my friends? All right, y'all. Hey, I'm enjoying your class. Y'all are a good group, so I look forward to seeing you next week. Have a good extended weekend in with Labor Day, and we'll see you next Wednesday at 9 o'clock. Question, Derek? No?
I think I missed something.
If I blurted out at any point, see you Monday, or the lab is due Monday, which I might do out of habit, we'll see you Wednesday. The lab is due Wednesday.
Can you slide up a little bit on the
The picture?
MR direct?
Oh.
For the syntax?
Here for RMDir. There you go. All right. You guys have a good weekend. I'm going to stop the recorder.